The question below uses a robot in a grid of squares. The robot is represented as a triangle, which is initially in the center square of the grid and facing towards the top of the grid. So, like this triangle here. The following code segment is used to move the robot within the grid. Okay. A gray square represents a possible final location of the robot after the code segment is executed. Which of the following represents all the possible final locations of the robot? So let's look at this code here. So the first line, we assign x the value of some random number between 1 and 3. So that means x can become either 1, 2, or 3. And then what we're going to do is repeat this block of code here inside the curly braces x times. So we're going to repeat this code here 1, 2, or 3 times. So we're going to rotate right 1, 2, or 3 times. So that's just changing the orientation of the triangle here. So rotating right once changes it to face to the right. And then rotating it twice makes it face down. And rotating 3 times makes it face to the left. Then after we rotate 1, 2, or 3 times, a variable y gets assigned a random value between 1 and 2. So y is either 1 or 2. And we're going to, similarly to what we did up here, we're going to repeat y times whatever's inside these curly braces. So we're going to either move forward 1 or 2 times. So what this code basically does is either rotates the robot 1, 2, or 3 times towards the right, and then moves forward 1 or 2 times. So let's model all of these cases here. So if we rotate right 1 time, our robot will be facing towards the right. It'll be facing in this direction. And then if we move forward 1 time, we'll take over this square here. Now, if we rotate right once again, or in a new, let's run this code again in a separate scenario where we rotate once, but then this time we move forward twice. So that means our robot will end up in this square. So now that was all the possible combinations for rotating right. Because if we rotate right once, we can either move forward once or move forward twice. But now let's rotate twice. So if we rotate twice, first we face to the right, and then we face down. So now that we're facing down, we're either going to move forward once and move into this square, or move forward twice and move into this square. So then so far, here, let me get rid of these circles. So we're going to be taking over these 2 squares here. Now, so we've finished rotating once and then rotating twice. Now let's rotate 3 times. So first we'll be facing the right, then down, and then left again. Rotating right in this case just means rotate clockwise, and that's going towards the right. So now we'll be facing towards the left, and we're going to move forward 1 or 2 times. If we move forward 1 time, we occupy this square, and if we move forward twice, we occupy this square. So that means these 6 squares here are the possible squares where after running this code, the robot will be placed in. So that's the same as answer choice B. And all we had to do was recognize that there cannot be up to 3 values for x and up to 2 values for y. So for every value of x, there are 2 possibilities. So 2 possibilities, then 2 possibilities, then 2 more possibilities. So that ends up being 6 total squares, and they all are moving forward once or twice and rotating once, twice, or 3 times, meaning that it filled up these 6 squares.